Assalamualaikum. Today we are going to present communication between client and service. Client-server application, an interaction between a client program that needed and used the resources or services provided by a server. There are four types of classes: host-based processing, where it is a traditional mainframe environment. Second, server-based processing, where is all the server do the processing. Client-based processing, where it is the most common client-server model. And cooperative processing, where all the application processing is performed in an optimized fashion. Architecture of client-server. First, three-tier client-server, whereas it is divided into three types of level, which is level 1, it is client, level 2 is application server, and level 3 is database. The process is where the level first, the client requesting through the application server, level 2, and the level 2 will go through to the database server, which is the level 3, to provide all the resources. Second, middleware. Middleware is a standardized interface and protocol between client and backend database. It hides the complexity of the data from the end user, and it is an application operates over a uniform of API, which is the application programming interface. Basic message passing primitive, sending process. Then it will go to the message passing module, where the package of the message will go to the next message passing module, and then it will go to the receiving processes. Message passing issues. First, reliability versus unreliability. Reliability is where the guarantee delivery and provide error checking for the message, while for the unreliability, it is where the message can be sent without success or failure, and it is also reduced complexity and overhead. Second, blocking versus unblocking. Non-blocking more efficient, but it is difficult to test. While for the blocking, it retains control until acknowledgement is received. That's all from me. Thank you.
My name is HANIF bin JAMALUDDIN, and I will be presenting on a remote procedure call. The goal of RPC systems is to make a remote procedure call look like an ordinary procedure call, because a service feels independently from a client. However, a remote procedure call can generally not offer identical semantics to procedure calls. RPC figure. So it has two processes, the client process and server process. So first, the caller will call procedure, and the server process will receive requests and start the procedure execution. And then after execution, it will send a reply back to the caller, and the caller will resume execution, and the server process will wait for next request. So the calling environment is suspended. Procedure parameters are transferred across the network to the environment where the procedure is to execute, and the procedure is executed there. When the procedure finishes and produces its results are transferred back to the calling environment, where execution resumes as if returning from a regular procedure call. Some RPC systems, for example, simplify the programming of clients and service by hiding many details of constructing and formatting messages. In the time service example in the previous slide, the programmer must call send underscore message and receive underscore message and convert results into numbers and so on. Stub is a piece of code that translates parameters sent between the client and server during a remote procedure call in distributed computing. An RPC's main purpose is to allow a local computer client to call procedures on another computer remotely server because the client and server utilize distinct address spaces. In most cases, stub libraries are installed on both the client and the server. Client stubs transform marshalling parameters used in function calls and then reconvert the result returned by the server when the function is completed. So here there are two machines, which are client machine and server machine. So the marshal invocation is passed across network between the two machines. So stubs can be created in two different ways: manual generation and automatic generation. So first, for manual generation, the RPC implementer provides a collection of translation functions from which a user can create their own stubs using this way. This method is easy to use and can handle a wide range of argument types. Next, for automatic generation, client and server interfaces are defined using IDL, which is Interface Definition Language. An interface specification, for example, contains information indicating whether each argument is input, output, or both. Only input arguments must be passed from client to server, while only output elements must be copied from server to client.
Assalamualaikum warahmatullahi wabarakatuh and good morning to Dr. Hasrul and friend. So I'm Muhammad Hadrin Jari, would like to present my part is multiple client and services, communication intermediary and intermediary devices. Okay, so first of all, we go to multiple client and services. We have 3 points of multiple client and services. So once service or server can work for multiple clients. Server can have function as database. All database can access by all client. Then number 2, one client can use several services. Client have constraint in terms of hardware performance, but client can also work such as server. And then number 3 is a single module can take one the roles of both client and service. A printer service might temporarily store documents on a file service until the printer is ready to print. Communication intermediary. So, for the communication intermediary is the primary purpose of the email intermediary is to implement buffer communication. Sending a message from a sender to a receiver requires that both parties be available at the same time. The intermediary can hold messages until the receiver comes online. The intermediary might buffer messages in volatile memory or in non-volatile memory. So we go to the intermediary devices. Intermediary devices connect the individual host to the network and can connect multiple individual networks to form an internetwork. Intermediary devices are not all the same. Some work inside the LAN performing switching functions, and others help route messages between networks. So, the table below lists some intermediary device and their function. Okay, so we have the device type and description. So, for the network access device is connect end user to their network. Example are hub, switch, and wireless access point. So for the device type of internetwork devices is connect one network to one more other networks. Router are the main, for example. Communication server. Road service such as IPTV and wireless broadband. So for the modem is connect user to servers and network through telephone or cable. And then lastly is security devices. Secure the network with devices such as firewall that analyze traffic exiting and entering the network. Okay, so the function of intermediary device is regenerate and retransmit data signal, maintain information about what pathway exists through the network and intra-network, notify other devices of errors and communication failures, direct data along alternate pathways when there is a link failure, classify and direct message according to quality of service QoS priorities. Okay, so we see the figure. Below depict two LANs with N device connected by intermediary switch in the LANs and router between the LANs. Okay, as we can see, we have the user, two user, and then the opposite of the have two user also. So they have the LAN, and then at the middle of the process is have internet work. So we can they can connect to the each other. Is in the internet work is the middle of the process. So that's all for me. Thank you.
Yeah, my name is ALIF. I present about system call. The system call provide the interface, the GUI between a running program and the operating system. Generally available as assembly language instruction. Language defined to replace assembly language for system programming allow system call to be made directly by example C and C++. Okay, next is the example of system call. Okay, you can see interface, go to application go to interface. On the top side, this is the for user mode, and bottom side is kernel mode. Okay, next type of system call. First one is process control, and then file management, device management, information maintenance, and communication. Process control create, execute, wait, and abort. That's what process control do. And file management can delete, create, open, close, read, write, and etc. Device management read, write, attach, detach, get, set, device attributes. Okay, that's what device management do. And for information maintenance is get, time or date, set, file attribute, device attribute, the everything specific that. Communication can send, receive, connect, set, the status information. Okay. So next is system program. System program provide a convenient environment for program development and execution. The system program can be divided into file manipulation, such as information, file modification, program language support, program loading and execution, communication and application program. So that's all for me. Thank you.